Good morning, dear students. I, Dr. Archana Razurkar from MGM's College of Engineering, Nanded, Department of Computer Science and Engineering, heartily welcome you all to the online lecture series of compiler design. I hope you all are fine, taking care of yourself and staying safe in this lockdown period. You all know that before the lockdown started, we had finished Unit 3, that is Syntax Analysis Part 1 in the classroom. We have discussed top-down parsing technique in detail along with the problem. But there was a request from few students that they wanted a quick revision of top-down parsing, and they also wanted one problem is to be taken in detail. So in today's lecture, we are going to have a quick revision of top-down parsing, and then we shall see one problem in detail which also explains the drawback or limitation of top-down parsing. So in the model of compiler, this is the position of parser. Here the position of the parser is such that it requests to the lexical analyzer that get me next token whenever required. Lexical analyzer will read the source program character by character, separate it into token and give this token to the parser. Now the responsibility of the parser is to combine these tokens to form a syntactic structure or a statement of the programming language. Now after constructing the syntax tree from the tokens, it will check that whether in that syntactic structure whether there is syntax error or semantic error. If any error is there, that is shown to the user. Now the output of the parser is syntax tree, which is given as an input to the next phase of compiler, that is intermediate representation. Now these two blocks, lexical analyzer as well as parser, are connected to the symbol table. So during lexical analysis, whenever the lexical analyzer finds identifiers, those values of the identifiers, constants and their attributes are saved in the symbol table. As and when required, the parser will refer these values. Similarly, all other phases of compiler also takes the values of identifiers and their attributes from the symbol table. Now we know that there are two types of parsers. The first one is top-down parser and the second one is the bottom-up parser. So there are two types of top-down parsers. First one is the recursive descent parsing, which uses recursive procedure to perform the predictive parsing, and second one is the LL parsing. Here the first L stands for reading the source program from left to right, and second L stands for use of leftmost derivation. And second type of parser is bottom-up parser, which evaluates the parse tree from leaf to root. Again, there are two types of bottom-up parsing techniques. The first one, operator precedence parsing, which uses operators precedence for parsing, and second, the most popular parser is called as LR parser. Now here the first L stands for reading the source program from left to right, and it uses rightmost derivation in reverse. There are three types of LR parsers. First one is a simple LR, second one is the canonical LR, and third one is the LALR. In today's lecture, we are going to see top-down parsers in detail. So this is an example of top-down parsing. As I already told you, the top-down parsing is also called as LL parsing, or it is also called as predictive parsing. So here the first L stands for reading the source program from left to right, and second L stands for the top-down parser uses leftmost derivation. Suppose there is a grammar given to us, E tends to T plus T, T tends to E enclosed in the bracket, T tends to minus E, and T tends to ID. Suppose there is a input string to be parsed is ID plus ID. So here LM stands for use of leftmost derivation. So see that how top-down parse tree is generated. Now to parse the input ID plus ID, we start with the first production, E tends to T plus T. Why this production? Because in the input there is a plus sign, so there is a probability that this production will give us successful parsing. So first E is expanded by E tends to T plus T. In second step, this T is expanded by ID. So now leaf nodes are ID plus T. In third step, the second T will be expanded by ID. And now if you check, the leaf node is same as that of the input, which is nothing but the leftmost derivation of E tends to T plus T. So what we can learn from this is that LL parsing uses leftmost derivation. So if we perform leftmost derivation of E tends to T plus T, we get the input ID plus ID, and same thing we can see that with the help of syntax tree, we can see that we can achieve successful parsing. Now there are three important conditions to be satisfied for top-down parsing or LL parsing to work accurately. The first thing is that the grammar used for LL1 parsing should not have any left recursion. Second is that the left factoring need not be required for the grammar in LL1 parsing. So first let's see, what do you mean by left recursion? So left recursion means the grammar is having a production of the form A tends to A alpha or beta or gamma. So you can see here the beta or gamma, these productions do not have any problem, but A tends to A alpha is a recursive production. A is getting repeated immediately at right hand side of the production. So if you try to expand A by A alpha n number of times, you cannot remove A. So if you replace for this A alpha, you will get A alpha alpha. Again if you try to replace first A by A alpha, again you will get A alpha alpha, and similarly A alpha 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 n number of times, and this may go till infinity. So this creates problem for LL1 parsing. So left recursion is not allowed. Now when one of the production, the definition of left recursion is when one of the productions in a grammar is left recursive, then predictive parser loops forever on certain inputs. So it is not allowed to have left recursive productions in the grammar. Now what is the solution for this? The solution for this is that we have to remove this left recursion using this algorithm. This algorithm we have already seen in the class in detail. We have also solved problems for removal of left recursion. Now second condition for the predictive parsing or LL1 parsing is that the grammar do not have the left factoring. Now what do you mean by left factoring? See, if I have production in the grammar A tends to alpha beta 1, alpha beta 2, alpha beta 3 till alpha beta n, and other productions are gamma. Now gamma production do not have any problem. Gamma means which do not start with alpha, but these productions they all start with alpha. So they create problem for LL1 parsing. How? Now since this is starting with alpha, this is starting with alpha, this is also starting with alpha, when there is an input alpha, the parser will be in a confusion whether to use the first production alpha beta 1 or alpha beta 2 or alpha beta n. And suppose the parser selects these productions randomly, then if alpha beta 1 is expected and parser chooses alpha beta 2, parsing will fail. Vice versa, if alpha beta 2 is expected and parser is selecting alpha beta 1, again the parser will fail. So what is the solution for this? Solution for this is left factor these type of grammar productions. So how do we left factor? We take out alpha common because alpha is same in all other productions. So you just take out alpha and remaining production we rewrite as A dash, or it is also called as AR. You can write anything. So alpha AR or gamma, that is other productions which do not start with alpha, are remaining as it is, and AR tends to other productions beta 1, beta 2, beta n. You can see that here we have removed the common things which are same in all other productions by taking alpha common. This is called as left factoring. So the first step for LL1 parsing is that we need to remove the left recursion. Second step is, if required, we have to perform left factoring on the grammar production. So now these are the steps here enlisted. The steps for predictive parsing are elimination of left recursion from the grammar, then left factor the grammar, then third step is computation of first and follow values. Now there are two variants of predictive parsing. First one is the recursive parsing, second is non-recursive parsing. In the recursive parsing, what happens? The recursive procedure calls are used to expand the non-terminals, and in non-recursive parsing, recursive procedures are not used. Rather than a table is used which is called as LL1 parsing table. So table will be giving the guidelines to the non-recursive parser that what action is to be taken at what point so that it can have a successful parsing. Now the third step for LL1 parsing is computation of first and follow values, because for construction of parsing table we should compute first and follow value. Let us see that what are the rules for computation of first. So first of alpha means what? The set of terminals that begin all strings derived from alpha. So how to calculate the first values? If the alpha is terminal such as A, then first of A is A. If alpha is epsilon, then first of epsilon is epsilon. The third is if alpha is non-terminal such as A. So first of A is nothing but first of right hand side of A. Suppose there is a production A tends to alpha. So first of A is first of alpha. Now the last rule is little complicated, that first of 3 or 4 continuous non-terminals. Here x1, x2, x3, xn stands for non-terminal. If all these are non-terminals, then how to compute the first value? If x1 do not derive epsilon, then we can directly write first of x1, x2, xn is first of x1. But if x1 derives epsilon, as shown here, epsilon is a member of first of xj, means that if x1 is deriving epsilon, means x1 can remain absent. In that case, I have to take first of x2. If x2 is also deriving epsilon, then I will have to go for first of x3 till xk. So this is a generalized rule that if first 2, 3, 4 non-terminals are deriving epsilon, then we have to go for the next non-terminal to compute the first value. So these are the rules for computation of first. Now let's see what are the rules for computation of follow. What do you mean by follow? Follow of non-terminal A means the set of terminals that can immediately follow non-terminal A, right? So any non-terminal A, whatever is the following terminal to that A is called as a follow of A. So these are the 4 rules for computation of follow. First rule is for all B tends to alpha A beta. What does it mean here? That before A there can be any terminals or non-terminals. After A also there can be any terminals or non-terminals. If this type of production is there, then how do we compute follow of A? Follow of A is equals to first of beta. Because beta can be terminal, it can be non-terminal. Another important thing is that beta can derive epsilon. If beta is deriving epsilon, then we have to take first of beta minus epsilon, because epsilon doesn't have any meaning that is following A. So add first of beta except epsilon to follow A. Take another case for all B tends to alpha A beta. If this kind of production is there in the set of production and epsilon is in first of beta, means beta can remain absent. If beta remain absent, then the production will become B tends to alpha A. In that case, follow of B is equals to follow of A. So add follow of B to follow of A. Now third case is that if we have production such that B tends to alpha A, here by default beta is absent. Here beta was deriving absent, so it was a possibility that beta may remain absent, but in this case beta is not at all there. So directly I can write follow of B equals to follow of A. And the last rule is that if A is the start symbol of the grammar, then what is following to the start symbol of the grammar? Dollar is following to the start symbol of grammar. Why dollar? Which is the indication that at this end the syntax tree is over in the top down parsing. If we reach to dollar means it is end of the parsing. Now here are few shortcuts to identify that whether a given grammar is LL1 or not. So if the grammar follows these rules, then we can quickly find out that whether a given grammar is LL1 or not. So this type of question can be asked in the multiple choice question type of questions, or for short answer questions for 2 marks. Any grammar will be given to you and you will be asked that prove that this grammar is not LL1. So how to find out whether a given grammar is LL1 or not? So a grammar G is LL1 if it is not left recursive. First condition is that the grammar should not have left recursion for each of the collection of production. A tends to alpha 1, alpha 2, alpha n. Then for this non-terminal A, the following condition should hold. What is the first condition? First of alpha I intersection first of alpha j should be empty. What does it mean? That starting of alpha 1, alpha 2, alpha 3, alpha n should not be same, because if this is same then we need to go for left factoring, and this will check that whether left factoring is required or not. If first of alpha I is same as that of first of alpha j, then it will not be empty. In that case left factoring will be required. The next condition is that if any of these productions alpha 1, alpha 2, alpha I, they derive epsilon in 1 or 2 steps, then alpha j should not derive epsilon, because if they derive then alpha 1 also will remain absent and alpha 2 also will remain absent. That is not allowed. So either one of them can derive epsilon, but both of them cannot derive epsilon. And the last rule is that first of alpha j should not be equal to follow of A. Means follow of A and first of alpha j should not be same, because if they are same, again they will create problem during LL1 parsing. That we will see with example that how first and follow values, if they are same, they create the problem. Let us see the examples. These are the examples of non-LL1 grammar. Suppose we have a production S tends to SA or A. Now is this a production is LL1? No, because this is a left recursion. S is immediately appearing at right hand side of the production. So because of left recursion, this production is not LL1. Let's take another example. S tends to AS or A. Now here this is alpha 1, this is alpha 2. Both of them are starting with A. So first of AS intersection first of A, it is not empty. Means this production requires left factoring. This production has to be rewritten, right? Before that, this production is not LL1. Then the next example is S tends to AR or epsilon and R tends to S or epsilon. Now here S is deriving epsilon and R is deriving S or epsilon. Means both productions are deriving epsilon, and that is not allowed. You have seen in the rule, right, that alpha j, if alpha I is deriving epsilon, then alpha j should not derive epsilon, and because of this reason this production is not LL1. And the last is S tends to AR A. Now here what is follow of A? Follow of R is small a, right, and R is deriving S. Then what is follow of S? Follow of S is also A. Now follow of S and follow of R are same, right? So intersection of these two is not empty. So first of S is small a, follow of R is small a, which is not allowed. So these grammar productions are examples of not LL1. Now in the non-recursive predictive parsing, this is also called as table driven parsing, because in this method a parsing table is used to give the guideline to the parsing program that how parsing should be performed. So in the non-recursive predictive parsing, we have got an input buffer where the source program is saved and which is at the end followed by a dollar symbol. Then there is a stack. The grammar symbols are saved on the stack. The stack is initialized with $. So when these two dollars match at the end, we say that parsing is successful. Then there are two important programs. First one is predictive parsing program. So this predictive parsing program takes the information from parsing table, that which production is to be used at what time to have a successful parsing, and as per the guidelines given in the parsing table, it makes the use of productions on the stack, and then top of the stack and input is matched. So we will see this with an example. So these two programs, one is construction of parsing table and predictive parsing program, we will see one by one. For construction of predictive parsing table, it makes use of first and follow value. So for each production A tends to alpha, we have to first calculate first of alpha. So for each A that belongs to first of alpha, we have to enter in the predictive parsing table the production A tends to alpha at row index A means non-terminal and column index A is the terminal. So first we have to compute first value of the production, and below the first value make the entry of production A tends to alpha. Now if the production is having epsilon, so if epsilon is there in the first of alpha, then for each B is a member of follow of A. So if epsilon is derived by the first of alpha, then we need to compute follow of A. If small b is a member of follow of A, then we have to add this production A tends to alpha at row index A and column index B, which is a follow value. So we will see all these things with example in detail. So let us see this problem in detail. So in the problem, the grammar is given as E tends to E plus T or T, T tends to T into F or F tends to E enclosed in the bracket or ID. Now consider the following grammar, construct an LL1 parsing table and test whether the following grammar is LL1. So if you observe the grammar, whether the first step is required, that is removal of left recursion. Yes, these are the two productions. So the first production is E tends to E plus T, which is having left recursion, and then T tends to T into F. It is also having the left recursion. So first is we have to remove the left recursion from first two production. So this grammar is having left recursion in first two productions, that is E tends to E plus T and T tends to T into F. So the grammar is not LL1. So first step to solve this problem is to remove left recursion from first to production and make it LL1. So to remove left recursion, we have to use the rule A tends to A alpha or beta. This kind of production is there. Here is a left recursion. To remove the left recursion, we have to rewrite it. How do we rewrite? Then instead of A tends to A alpha, we will be writing A tends to beta A dash, and A dash will be replaced by alpha A dash or epsilon. So if you expand this beta A dash by A alpha A dash, you will get beta alpha A dash, and second time you will put epsilon for A dash, then you will get beta alpha. And if you see the original production for this A, if I put beta, I am going to get beta alpha, means I am going to get the same meaning from the rewriting. That is the proof that whatever rewriting you have done is correct, because you have not changed the meaning of the grammar. The same thing you have to apply on the production E tends to E plus T. So similarly, E tends to E plus T or T can be rewritten as E tends to T E dash and E dash tends to plus T E dash or epsilon. Now the other production T tends to T into F, this is also having left recursion. So this can be rewritten as T tends to F, which is a beta T dash, and T dash is this alpha star F T dash of epsilon. So after removal of left recursion, my original grammar has become this type of grammar now. E tends to T dash, E dash tends to plus T dash or epsilon, T tends to F T dash, T dash tends to star F T dash or epsilon, and F tends to E enclosed in the bracket or ID. Now next step is, after the removal of left recursion, the next step is computation of first and follow. So to compute first production E, we have to consider the production E tends to T E dash. So first of E is equals to first of T, right? Now T is also non-terminal. So to compute first of T, we have to consider the production T tends to F T dash. So again, first of T equals to first of F. To compute first of F, we have to consider the production F tends to E enclosed in the bracket or ID. Now here first of F is opening bracket comma ID. So first of F is opening bracket comma ID. Since opening bracket and ID are terminal symbols, as per the rule 1, we can write now first of E equals to first of T equals to first of F, which is equals to opening bracket comma ID. Now to compute first of E dash, we have to consider the production E dash tends to plus T E dash or epsilon. Then first of E dash equals to plus comma epsilon. So plus comma epsilon. Then to compute first of T dash, consider the production T dash tends to star F T dash or epsilon. So first of T dash is equals to first of, because these are two productions, I have to take union to compute the first. First of star F T dash union first of epsilon, that is equals to star comma epsilon. So now the computation of follow. To compute follow of E, let us consider the production E tends to T E dash, because E is the start symbol of the grammar. As per the rule 1, the follow of E is equals to $. Now in addition to this, consider the production F tends to E enclosed in the bracket or ID. Now why to take this production? Because we wanted to calculate follow of E. So we have to take all the production where E is at the right hand side. So in the given grammar, there is only one production, F tends to E enclosed in the bracket, where E is at the right hand side of the production. So now what is following non-terminal E? Closing bracket is following non-terminal of E. So as per the rule 4, follow of E equals to $. So dollar is already in the follow of E, and as per this production, follow of E is closing bracket. So closing bracket is added in the follow of E. So follow of E equals to $, comma closing bracket. Now to compute follow of A dash, we have to see the production where A dash is at the right hand side. So consider the production E tends to T E dash. Now match this production with the rule 3 of follow. What is the rule 3 of follow? For all B tends to alpha A that belongs to the set of productions P, do add follow of B equals to follow of A. The meaning is after A nothing is there. A is the last non-terminal. So in this case, follow of B is equals to follow of A. So we can write using this rule, follow of E dash equals to follow of E. This is a follow of E dash equals to follow of E. Follow of E we have already calculated, that is $, comma closing bracket. So follow of E dash is also $, comma closing bracket. Now the next non-terminal is T. So to compute follow of T, consider the production where T is at right hand side. So let's take the production E dash tends to plus T E dash or epsilon. Again using the same rule number 3, we can write follow of T is equals to, what is following T? E dash is following T. So follow of T equals to first of E dash. So first of E dash minus epsilon, because as per the rule we should take the terminal symbols except epsilon, because epsilon doesn't have any meaning, it is an empty string. So first of E dash is plus comma epsilon. So since E dash tends to epsilon, it may remain absent. So in that case we have to take E dash tends to plus t. So again matching it with the rule 3 of follow of t equals to follow of E dash. Follow of E dash we have already calculated. So first of E dash minus epsilon using this rule. So what is first of E dash? First of E dash is plus comma epsilon, minus epsilon, epsilon will get cancelled. So plus union with follow of E dash. Follow of E dash is dollar comma closing bracket. So at the end now we can write follow of t equals to plus comma closing bracket comma dollar. Now to compute follow of t, we have to consider the production t tends to ft dash, right? Now again matching it with the rule 3 of follow of t equals to follow of t dash. Now follow of t just now we have computed, that is plus closing bracket and dollar. So follow of t dash equals to follow of t equals to plus closing bracket dollar. Now to compute follow of f, consider the production where f is at right hand side. So consider the production t dash tends to star ft dash or epsilon. So follow of is f is nothing but first of t dash. So follow of f equals to first of t dash, that is star comma epsilon. Since t dash derives epsilon, it may remain absent. In that case we get the production t dash tends to star f. Again matching this with rule 3 of follow, I can write follow of f equals to follow of t dash. So follow of t dash is nothing but first of t dash minus epsilon union follow of t. So first of t dash is star and follow of t just now we have computed is plus closing bracket and dollar. So finally we can say that follow of f equals to star comma plus comma closing bracket comma dollar. So this is how to compute the follow of all non-terminals. Now this is the summary of first and follow values. First of E equals to first of T equals to first of F, which is equals to opening bracket comma ID. First of E dash equals to plus comma epsilon. First of T dash equals to star comma epsilon. And then follow of E and follow of E dash are same, that is closing bracket dollar. Follow of T and follow of T dash is same, plus closing bracket dollar, and follow of F is plus closing bracket star and dollar. Now to write the parsing table, we have to see how many rows the parsing table will have. So the number of rows is equals to number of non-terminal of the grammar. So there are 5 non-terminals in the grammar. So rows are equal to 5 and the columns are equal to the terminal symbols of the grammar. So there are 6 terminal symbols in the grammar. So the number of rows in the parsing table will be 6. Now let us construct the parsing table one by one. So take the first production, E tends to TE dash. For this we have to say that what is the first value of E. Now first value of E is nothing but opening bracket comma ID. So simply write at row index E, column index ID, E tends to TE dash, as well as at row index E and column index opening bracket, because it is first of E. So below the first values we have to write that production. Since E did not derive epsilon, we don't bother about the follow of E. Now take the next production. Next production is E dash tends to plus T dash or epsilon. So first calculate the first of E dash, that we have already calculated, that is plus comma epsilon. So below plus I am going to write that production E dash tends to plus TE dash. The meaning is when input is plus and top of the stack is E dash, we have to use this production. The meaning of this, when the input is ID, top of the stack is E. In the non-recursive predictive parser, we have to use the production E tends to TE dash. Similarly, when opening bracket is in the input and top of the stack is E, we are supposed to use E tends to TE dash. Now the third production is t tends to star ft, t tends to ft dash. So compute first of t, that we have already computed. First of t equals to star comma first of t equals to opening bracket comma id. So below id and opening bracket we are supposed to write t tends to ft dash. The next production is t tends to star ft dash. So for next production we have to compute first of t dash. First of t dash is star comma epsilon. So below star we have to write the production t dash tends to star ft dash. Now since t dash derives epsilon, we have to compute follow of t. Follow of t is nothing but plus closing bracket and dollar. So t dash is having two productions. One is star ft dash, another is epsilon. So below star we have already written the production t dash tends to star ft dash. Now for epsilon we have to compute follow of t dash. Follow of t dash is plus closing bracket dollar. So below plus closing bracket and dollar we should write the second production of t dash, that is t dash tends to epsilon. Now finally the last production is f tends to e enclosed in the bracket or id. Okay. Now for that I have to consider row index f, column index id and write the production f tends to id, and there is another production f tends to e enclosed in the bracket. So first of f is nothing but opening bracket and id. So below opening bracket we should write f tends to opening bracket e closing bracket. The meaning is that when the top of the stack is f and input is opening bracket, we should use this production, and when the top of the stack is f and input is id, we should use the production f tends to id. So using this method there is no confusion for the predictive parser that which production is to be used at what time, and there will not be any mistake made by the parser in randomly selecting the production. So this is the working of top-down parser for an example grammar. Now let's see what are the drawback of this grammar. For explaining the drawback of the grammar, let us consider one more problem. So consider the following grammar: S tends to IET SS1 or A, S1 tends to ES or epsilon, E tends to B. The problem is prove that above grammar is not LL1 by constructing predictive parsing table. Now the solution of this problem is, the first we have to check that whether the given grammar is having left recursion. So there is no left recursive production in the given grammar. Then you have to see that whether left factoring is required. No, there is no left factoring is required in this grammar. Now the next step is to compute first and follow. To calculate first of S, we have to see what are the productions of S. S is having two productions, IET SS1 and S tends to A. So first of S equals to first of IET SS1 union first of A. First of IET SS1, now since I is a terminal symbol, I can take directly first of S equals to I, and A is also terminal, I get small a. So I comma A is there in the first of S. Now second production is S1. S1 tends to ES or epsilon. Again there are two productions. So first of S1 equals to first of ES union first of epsilon. First of ES is E because E is a terminal, and epsilon is also can be directly taken as a first of S1. It is also a terminal symbol. Third production is E tends to B. Now B is a terminal symbol, so I can directly write first of E equals to first of small b, that is B. Now to compute follow of S, S is a start symbol of the grammar, so dollar will be there in the follow of S equals to dollar. Now again see that is there any S at right hand side of the production? Yes, these are the two productions where S is at right hand side. So consider the production S tends to IET SS1. So as per this production, what is following S? S1 is following S. So follow of S equals to first of S1. What is first of S1? First of S1 is E comma epsilon, right? So follow of S is E comma epsilon minus epsilon, because we should take in the follow the terminal symbols except epsilon. So follow of S equals to dollar union E comma epsilon minus epsilon. Dollar we have computed because S is a start symbol of grammar. So finally we get follow of s equals to dollar comma e, and epsilon will get cancelled. Now consider the next production, S1 tends to ES. So as per the rule 2 of follow, now follow of S1 equals to follow of S. So follow of S we have already computed, E comma dollar. So follow of S1 is E comma dollar. Now to construct the parsing table, number of rows equals to number of non-terminals S1, S and E. Number of columns are equals to terminal symbols of the grammar I, A, B, E, T, S. Now for S and I, see the production of S. What are the production of S? S is tends to I, E, T, S, S1 or A. So for the input I will writing the production. The first of S is nothing but I comma A. So below I will be writing the production S tends to I, E, T, S, S1 because this production starts with I and there is a possibility of match. Now when the input is A, we are going to use the second production, that is S tends to A. So when we had two productions, one is starting with I, another is A. So in the parsing table we are giving clear cut instructions that when input is I, use the production which starts with I, that is S tends to I, E, T, S, S1. When the input is A, use the production that starts with A. Now for next production S1, what is the production is? S1 tends to ES or epsilon. Now what is first of S1? First of S1 is E comma epsilon. Since first of S1 is E comma epsilon, I will be writing S1 tends to ES below E, and now for epsilon, because S1 is deriving epsilon, I need to compute follow of S1. Now what is follow of S1 is E comma dollar. So below E comma dollar, I should use the second production of S1, that is S1 tends to epsilon. So I will be writing below E S1 tends to epsilon and below dollar S1 tends to epsilon. Third production is E tends to B, whose first value is B. So below B I will be direct, row index is E, column index is B, I will be directly writing E tends to B. Now what is the problem with this parsing table is that it is giving multiple entries at single location. Now why this is happening? Because first of S1 is consisting of E comma epsilon and follow of S1 is also consisting of E. Means first of S1 equals to follow of S1, that is E. Because of this we are getting multiple entries at single location. So when there are multiple entries at single location, the parser will be in a confusion that when input is E, top of the stack is S1, whether to use S1 tends to ES or to use S1 tends to epsilon. Now if parser randomly selects S1 tends to epsilon and this is expected, parser will fail. And when parser will randomly select this and this is expected, again parser will fail. So whenever there are multiple entries in a parsing table, the grammar is not LL1. So what can be the answer of this question? Prove that the grammar is not LL1. What justification you can write? The parsing table constructed by LL1 parser generates multiple entries at single location. So the parser is not LL1. Now I would like to explain you the entries on the stack for this example which we have already seen. So see that how exactly the parser works. Yeah. For this example we have already seen that E tends to TE dash for this problem. Yeah. For this problem, instead of E dash, they are written here in the PPT as ER. ER and E dash are same. So the same grammar is there. E tends to TE dash, E dash tends to plus TE dash or epsilon, T tends to FT dash, and T dash tends to star FT dash or epsilon, F tends to E enclosed in the bracket or ID. So let's see how exactly the parser work. See, this is the stack, this is the input. Suppose the input given to us is ID plus ID into ID followed by dollar, and we want to parse this input. So what is the start symbol of the grammar? Start symbol of the grammar is E. So we will be pushing first the start symbol of the grammar onto the stack. So E is entered onto the stack and the buffer contains id plus id into id followed by dollar. Now see here, E and id cannot be matched because E is non-terminal. So we have to search the parsing table. How do we search? The row index is E and column index is id. If you see our example, so if you see our example, we search the parsing table with row index E, column index id. Which production is written here? E tends to TE dash. So I will be popping out E from the stack as per the algorithm and pushing the right hand side of the production TE dash in the reverse order onto the stack. So TE dash will be pushed onto the stack as a E dash T. Now top of the stack is T and ID will be matched. Again the two cannot be matched because this is non-terminal. So we'll have to search the table with row index T, column index ID. So search row index T, column index id. What is the production written here? T tends to ft dash. So take T tends to ft dash and push it onto the stack in the reverse order. So I'll be pushing on T dash f. Now f and id cannot be matched. So again search row index f, column index id. So row index f, column index id. I'm getting the production f tends to id. So push id, pop out f from the stack and push id onto the stack. Now id is getting matched. So the input buffer forward pointer is incremented by 1. Now it is pointing to plus. Now plus is also a terminal symbol and T dash is a non-terminal. So T dash and plus cannot be matched. So search the table with T dash comma plus. So T dash comma plus. What is written here? T dash tend to epsilon. So here you can see that as per the guidelines given by parsing table, we are selecting the production. So for T dash I am going to put epsilon. So I am getting now on the top of the stack E dash. So again E dash remaining output is as it is. Now E dash and plus cannot be matched. Now I have to search the table with E dash comma plus. Now E dash comma plus is E dash tends to plus TE dash. So use E dash tends to plus TE dash production to pop out E dash from the stack and push plus TE dash in the reverse order onto the stack. Now plus plus getting matched means this input is parsed, forward pointer is incremented to ID. Now ID and T cannot be matched. So search the table with row index T, column index ID. So search the parsing table with row index T, column index ID, that is T tends to ft dash. So pop out T from the stack and insert ft dash in the reverse order onto the stack. Now f and id cannot be matched. Again search the table with f comma id. You will find in the parsing table f tends to id. So pop out f, push id will get matched. Increment the pointer. Now pointer is pointing to star. So star and T dash cannot be matched. So search the table with T dash star. You will find the production. T dash tends to star ft dash. So pop out T dash and push star ft dash onto the stack in a reverse order. Now star will get matched. And remaining input is now id dollar. Id f cannot be matched. So use the production f tends to id written in the table. Pop out f, push id will get matched. Dollar is remaining. Now dollar and T dash cannot be matched. So search the table with T dash comma dollar. So you can find here T dash comma dollar. You will find T dash tends to epsilon is the production to be used. So pop out T dash, insert epsilon. What is remaining is E dash. Search the table with E dash comma dollar. Again you will find the production E dash tends to epsilon. So now remove the E dash, pop out and push epsilon onto the stack. So remaining is dollar. Now dollar and dollar are getting matched. We have passed the input successfully. This is how the table driven predictive parser works. So we will now stop for this lecture. In the next lecture we will see the bottom up parsing. So today we have finished top down parsing with example problem, and in the next lecture we will start the bottom up parsing techniques. Thank you.